Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Today, inshallah, we'll complete our lesson, the atom. Today, inshallah, we'll talk about the structure of the atom. Starting with protons. As we said, protons, they are negatively charged, right? But let's know more about the protons today. Protons, guys. Protons are positively charged, so they carry positive charge particles of an atom. The relative charge of a single proton is often written as positive 1. So if we have one proton, that means positive 1. One proton. Two proton, two positive 2 or 2 positive, right? Very good. Now, the mass of a proton is very small. It's about 1.7 times 10 power to negative 24 so gram. It's so small. As you see, this number, so it's so small. The masses of particles in the atom are so small that scientists made a new unit for them, the unified atomic mass. So we made a new unit called atomic mass unit. The mass of the proton is about 1 unit. Neutron. Today we'll talk about neutron also. Neutron are particles that no positive charge, no negative charge, right? So no electric charge they have. They are a little more massive than proton are, so they are bigger than proton. But the mass of the neutron is still very close to 1 U. So it's approximately equal to the mass of the proton. Atomic usually have at least atoms usually have at least as many neutron they have proton. In atoms we can find many protons, or there are more neutron than proton, or less proton than neutron. Together, proton and neutron form the nucleus of the atom. So the nucleus consists of what? This is the nucleus of the atom. Consists of what? Proton with positive charge and neutron without any charge. No charge for neutron. Okay, guys, right. The nucleus is located at the center of the atom. So the center of the atom is what? The nucleus at the center. Okay, the nucleus also, this model of beryllium atom show the nucleus of the atom made up of 4 protons. 1, 2, 3, 4. We have 4 proton or 4 positive, right? Okay, and 5 neutron. Because each proton has 1 positive charge and neutron don't have any charges, now we can conclude that all the nucleus is positive charge, right? Okay, so overall charge we have positive 4 because of the 4 protons. Yes, remember, neutron have no electric charge. The volume of the nucleus is very small compared to the rest of the atom. So the volume of the nucleus is very small according to the atom. But proton and neutron are the most massive particle in the atom. So the nucleus is very dense. Of course, it's dense according to the atom, not according to the matter generally, right? If it were possible to have a nucleus to volume of a graph, that nucleus would have mass greater than 9 million metric ton. It's extra information. Electron cloud. The electron cloud. To understand the meaning of electron cloud, just imagine that there is a fan, right? We know that the fan like that. I'm good in drawing. Yes. A fan, right? Okay. It's at rest now, it's not moving. So you can see the blades. I can see one blade, two blades, three blades, right? But after turning on the fan, what will happen? The blades start to spin very, very fast, and you can only see something like that, right? So can you say that where is the blade exactly? Can you say that? Of course not. Can you see the blade is here? Is it? No, the blade's everywhere in the same time, of course, because they are moving so fast. Understood now? That the meaning of electron. In that example, as we said, you cannot say where is or where are the electron exactly they are. So the the electron cloud, the negatively charged particle of atom, are called electrons. We know that electrons move around nucleus very quickly, so fast. Scientists found that it's not possible to determine both their exact position and speed at the same time because they are spinning so they are rotating and revolving around the atom and around the nucleus so fast, right? Okay, this why we picture the electron as the beginning of in the electron cloud around the nucleus. Compare, can we see now? We represent the electron cloud like that, in that way. We cannot say exactly here electron or here electron. No, the electrons are moving in all this space in the same time so fast. So we called it's a cloud because in any time you can find an electron moving so fast. Understood now? Thank you. Now, let's turn back to our lesson. Compared with proton and neutron, electron have very little mass. It can take more than 1,800 electrons to equal the mass of one proton. So they are so small. The mass of an electron is so small that is usually thought of almost 0 U. So you can neglect what the mass of electron. You can say it has 0 U, 0 unit, 0 unit the mass of the electron. But I can neglect, the mass is neglected, yes, but the charge is neglected? No, it has negative and strong negative charge. So the charge of proton and electron are opposite. Proton positive, electron negative. And usually the number of proton equal to the number of electron. For example, 4 proton, 4 electron. In that case, 4 positive, 4 negative, they will cancel each other. That's why all atom usually is neutral or has no charge. Let's see. The number of proton in the atom equal to the number of electron. So the atom has a net or overall charge of 0. For example, this beryllium atom contains 4 electrons. That combined charge of the electron is negative 4. But remember that the charge of the nucleus is positive 4. So positive 4 and negative 4, they will cancel each other and the net will be 0. So the charge of the atom, the entire atom is 0. Is it now? Right. An atom can lose or gain electron when this happens. We refer to the atom, oh my god, it's a new term here, ion. So, may the atom gain or lose electron? May the atom can gain or lose electron. Gaining or losing electron, it's not atom anymore. We call it what? ion, because in that case it has a charge. It has a charge. Listen here to this example. Sodium atom. Now we are talking about what? Sodium. It has what? The nucleus here inside it, where it's 11 proton, and there is 11 electron moving around it. So it's 11 electron. Sometimes sodium, guys, now the atom overall is 0, because positive 11 and negative 11, so they will cancel each other, then it will be 0, right? But sometimes sodium lose one electron. One electron is lost, so it will be only 10. Now we have 11 positive or 11 proton and only 10 negative. So the difference between them will be positive 1. In that case, the atom has a charge of positive 1. And in that case, it's not atom anymore, it's called ion. Is it till now? Okay. Another example for that, chlorine, Cl. It has what? 17 proton, and around it you have what? 17 electron, or 17 negative, right? Or 17 negatively charged. Sometimes the chlorine gain another electron from outside. What happened? In that case, in the first case, it was first 17 positive and 17 negative, so the overall will be 0, right? In that case, after gaining one electron, become 17 positive but 18 negative. The result will be negative 1. Now the atom has a charge, and it's also not atom, it's what? Ion. Which kind of ion? It's negative ion. If it's positive, it will be positive ion, but now it's what? Negative ion, because the negative is more than the positive. Okay, let's continue, guys. We'll talk about the atomic number. What the meaning of atomic number? It's very easy. The atomic number is the number of proton in an atom, or the number of proton in nucleus of an atom. So the number of protons represents what? The atomic number. So if we have 7 proton, that means the atomic number is 7. Is it now? Okay, it's very simple. So if we have 9 proton, so it means the atomic number is 9, 5, 5, so on. So the atomic number represents what? The number of proton in an atom. Is it now? Okay. And now we'll talk about kind of numbers. It's called what? The mass number. The mass number represents what? The number of proton plus number of neutron. But Mr. Can the mass number be different in the same element? Yeah. Why? Because all atoms, they have the same number of proton, the same number of electron, but maybe they have different number of neutron. Let's see here. The atoms of a certain element always have the same number of proton, but they may not always have the same number of neutron. For example, as chlorine atom have 17 proton, but some chlorine atoms have 18. So other chlorine atoms have 20 neutrons. So you can see here the number of proton and electron, they are constant or fixed in all elements, or the same element, I mean, right? But you can find in the same element different number of neutron, as we see neutron in chlorine maybe 17, 18 or 20. These two types of chlorine atoms are called what? Isotopes. It's called what? Isotopes. Isotopes are atoms of the same element that have different number of neutron. Of course, because the number of neutron it changed, the number of the mass number also will be changed because the mass number is equals what? Yes, the proton number plus neutron number. The total number of proton and neutron is n is n atoms. Nucleus is what? Mass number. Different isotope of chlorine have different mass number. What is the mass number of chlorine atom that contains 18 nitron? Let's see here, 17 number of protons plus 18 number of neutron equal 35 and doesn't have any unit. It's a mass number only, right? Okay. You can see, so the atomic number here, use this model of helium to find the atomic number of and mass number. The atomic we can see 2 proton, so it's 2, and we can see 2 proton and 2 neutron, so the mass number is 4. Is it now? Okay. And by the end of the video, I hope you enjoyed it. See you next time. Inshallah. Goodbye.